Have you ever faced a frustrating issue while coding, especially when you're trying to implement something as tricky as setjmp and longjmp in C? If that's you, you're in the right place. Today we're diving into a common problem that many students encounter when working on these functions. I totally understand how challenging it can be to implement these functions without using built-in functions or assembly. You're not alone in this struggle. Many students find themselves stuck with incorrect return values, and it can be really confusing. Here's the specific situation we're looking at. One user mentioned that they keep getting wrong return values when calling their functions. They expected the program to return to main with a specific value, but instead, they encountered a segmentation fault. Sound familiar? Let's break this down together. So what could be causing this segmentation fault and incorrect return values? It often comes down to how pointers are being managed in your code. We'll explore the implementation of setjmp and longjmp to identify where things might be going wrong. And stick around. By the end of this video, you'll have a clearer understanding of how to fix these issues and get your code running smoothly. To address the issue with the incorrect return values, the user should first ensure that the setjmp function correctly saves the context. This involves storing the return value in a global variable. Next, the user should adjust the longjmp function to properly restore the context. This means it should set the return value to the saved context and jump back to the saved location. After implementing these changes, the user should test the functions by calling foo from main. This will allow the user to see if the return values are now correct. Finally, the user should ensure that the bar function calls longjmp correctly. This is crucial for the flow of control to return to main with the expected value. Fun fact, the concept of setjm and long is so powerful that it allows you to jump back to a previous state in your program, almost like a time machine for your code. Just remember, with great power comes great responsibility. Now, let's look at the answers provided by other users. This user suggests that implementing setjmp and longjmp requires access to the stack pointer, which is restricted in your assignment. They point out that the definitions of setjmp and longjmp in your code are incorrect, as the argument should be an array type, not an int. To find the old stack pointer, they recommend defining an array on the stack and accessing it with an offset. This method may vary based on your compiler and function arguments, so experimentation is necessary. Additionally, they mention that compiler optimizations can complicate the process, especially on certain architectures, and suggest disabling these optimizations or using a dummy function to ensure the link register is saved on the stack. That's it for that response. Let's explore another one. This user suggests a different approach to implementing setjmp and longjmp. They emphasize the importance of managing the link register, stack pointer, and frame pointer. By using a dummy function, they can save these registers on the stack, allowing for proper restoration during longjmp. They explain that setjmp should call a dummy function to store the link register and frame pointer, which can then be accessed globally. Longjmp will restore these values, ensuring that the program returns to the correct state with the desired return value. Finally, they recommend compiling with optimization disabled to prevent the compiler from inlining functions, which could disrupt the intended behavior. They also suggest using debugging tools to step through the program and understand the stack frame. Here's a pro tip. Always initialize your pointers before using them. This simple step can save you from many headaches and segmentation faults in your code. And there you have it. With these adjustments, your implementation of setjmp and longjmp should work as expected. Remember, debugging is part of the learning process. If you found this video helpful, don't forget to subscribe for more coding tips and tricks.